Hello everyone, this is Jayanthi working as an assistant professor in the Department of Physics at the Standard Fireworks Rajaratnam College for Women, Sivagasi. So now we are going to see about the course Material Science and IPR, in which we are going to study about the classification and selection of materials. These are all the learning objectives. In this topic, we are going to learn about the historical perspectives of materials. The learners able to classify the types of materials, and they are also able to analyze the factors affecting the selection of materials, and the learners may able to learn the engineering requirements of the materials. Before getting into this topic, let us see about what are the materials. Materials are nothing but they are defined as a substance of which something is composed or made. We obtain materials from earth crust and atmosphere. Examples: silicon and iron constitute 27.72 and 5% of weights of earth crust respectively, and also nitrogen and oxygen also constitute 78.08 and 20.95% of dry air by volume respectively. Next one is the historical perspectives. The earliest humans had access to only a very limited number of materials, those that occur naturally. Examples: stone, wood, clay, skins and so on. As the time goes on, they discovered different techniques to produce new materials. Examples: pottery and various metals. As the time goes further, they discovered the properties of a material which could alter by heat treatments and also by the addition of other substances. The development of many technologies that make our existence so comfortable, which has been intimately associated with the acceptability of suitable materials. And next one, we are going to see about the material science and engineering. So, material science and engineering plays a vital role in the modern age of science and technology. So, various kinds of materials are used in industry, housing, agriculture, transportation, etc. to meet the plant and individual requirements. The rapid developments in the field of quantum theory of solids have opened vast opportunities for better understanding and utilization of various materials. The term material science and engineering combines with both material science and materials engineering. Material science is at the basic knowledge end of the materials knowledge spectrum, and the material engineering is at the applied knowledge, and there is no demarcation line between the two. Materials may be defined as a substance of which something is composed or made. Mankind materials and engineering have evolved over the passage of time and are continuing to do so. And this figure shows a 3-stage diagram that indicates the relationship among the basic sciences, material science and engineering, and other engineering disciplines. The basic sciences are located within the first stage or core of the diagram, while the various engineering disciplines are located in the outermost, that is the third stage. The applied sciences, metallurgy, ceramics and polymer science are located in the middle or second stage. Material science and engineering is shown to form a bridge of materials knowledge from the basic sciences to the other engineering discipline. And next one is the classification of materials. So, materials are classified as metals, ceramics and polymers. In addition to this, they are also classified as composites, semiconductors and biomaterials. And this table shows the factors affecting the selection of materials. So, the selection of a specific material for a particular use is a very complex process. However, one can simplify the choice if the details about the operating parameters, manufacturing processes, functional requirements and cost considerations are known. There are thousands and thousands of materials available, and it is very difficult for an engineer to possess a detailed knowledge of all the materials. However, a good grasp of the fundamental principles which control the properties of various materials help one to make the optimum selection of materials. So, in this respect, material science and engineering draw heavily from engineering branches. Example: metallurgy, ceramics and polymer science. And next one is the engineering requirements. So, while selecting materials for engineering purposes, properties such as impact strength, tensile strength, hardness, and these indicate the suitability for the selection, but the design engineer will have to make sure that the radiography and other properties of the material are as per the specifications. One can dictate the method of production of the component, service life, cost, etc. However, due to the varied demands demands made metallic materials, one may require special surface treatment, example hardening, normalizing to cope with the surface requires. Besides, chemical properties of materials, example structure, bonding energy, resistance to environmental degradation also affect the selection of material for engineering purposes. So, in recent years, polymeric material or plastics have gained considerably popularity as engineering materials. Though inferior to most metallic materials in strength and temperature resistance, these are being used not only in corrosive environment but also in the places where minimum wear is required. Example, small gear wheels which are originally produced from hardened steels are now manufactured from nylon or Teflon. Thus, before selecting a material or designing a component, it is essential for one to understand the requirement of the process thoroughly, operating limitations like hazardous or non-hazardous conditions, continuous or non-continuous operation, availability of raw materials as well as spares, availability of alternate materials, its lifespan of the instrument, equipment, cost, etc. So, different materials possess different properties to meet the various requirements for engineering purposes. And next we are going to discuss about the properties of the materials. So, one of the properties is the mechanical property. So, the important mechanical property affecting the selection of the materials are tensile strength, hardness, ductility, impact strength and wear resistance. Now, let us discuss one by one. First, what is tensile strength? So, this enables the material to resist the application of a tensile force. To withstand this tensile force, the internal structure of the material provides the internal resistance. And next one is the hardness. It is the degree of resistance to indentation or scratching, abrasion and wear. Allowing techniques and heat treatment help to achieve the same. And next one is the ductility. This is the property of a metal by virtue of which it can be drawn into wires or elongated before rupture takes place. It depends upon the grain size of the metal crystals. And next one is the impact strength. It is the energy required per unit cross-sectional area to fracture a specimen. That is, it is a measure of the response of a material to shock loading. And last one is the wear resistance. It is nothing but the ability of a material to resist friction wear under particular conditions. That is, to maintain its physical dimensions when in sliding or rolling contact with a second member. The next property of the material is the thermal properties. The characteristics of a material which are functions of temperature are termed as thermal property. So, one can predict the performance of a machine components during normal operation if he or she has the knowledge of thermal property. Specific heat, thermal conductivity, thermal resistance, thermal diffusivity and thermal fatigue are few important thermal properties of the materials. And these properties play a vital role in selection of material for engineering applications. And next one is the magnetic property of the material. Materials in which a state of magnetism can be induced are termed as magnetic materials. There are 5 classes into which magnetic materials may be grouped: diamagnetic, paramagnetic, ferromagnetic, antiferromagnetic and ferrimagnetic. Iron, cobalt, nickel and some of their alloys and compounds possess spontaneous magnetization. Magnetic oxides like ferrites, garnets could be used at high frequencies because of their excellent magnetic property along with their high electrical resistivity. These materials today find in use in a variety of applications like magnetic recording tubes, inductors and transformers, memory elements, microwave devices and recording hard cores, etc. Hysteresis, permeability and coercive forces are some of the magnetic properties of magnetic substances which are to be considered for the manufacture of transformers and other electronic components. Thank you for watching this video.